Hey everybody. So what we'll speak today is some results, some preliminary results arising from the Savemedcoasts project, which is funded by European Union Humanitarian and Civil Protection. And the goal of the project is try to identify the coastal zones of the Mediterranean, which are more prone to sea level rise. Sea level is rising at faster rates than in the previous centuries, and is accelerating in recent years with the rise in the global temperatures. So we expect that mean sea level will rise more than 75 centimeters by the end of the century, but different projections provide even more values, higher values. So this is among the most serious impacts of climate change that we have to face in the next year. And we have to take into account that sea level rise can be locally higher than these predictions because the intervening of land subsidence, because it must be taken into account for coastal zones we are undergoing to land subsidence, like Venice, for example. And land subsidence will amplify the effects of sea level rise, of marine flooding, and the loss of land. And then the latter will be subtracted to human activities, and so with social and economical impact on local population. So, and even in addition, in a sea level rise environment, the tsunamis and storm will be amplified. The effect of tsunami and storm will be amplified. This is a map of the Mediterranean. In red shown the coastal plains of the Mediterranean, which are located at within 2 meters above sea level. And these are the areas which are most prone to sea level rise and tsunamis and storms. We have identified 163 coastal plains, and they have a surface, the amount of surface is about 5.5 million of soccer fields, just to give you an idea of the area that is prone to sea level rise. So the plot shows the local sea level, so the relative sea level rise projection for each one of the coastlines of these coastal plains. And values are very different because of the intervening coastal uplift, for example, tectonic uplift or coastal subsidence. To account for land subsidence, we use GPS data, remote sensing data, and we analyze sea level data from tight gauge networks. And for Northern Africa, where we have a lack of instrumental networks, we may use the geological indicators like the 5E marine terraces of 125,000 years ago, when sea level was about 7 meters higher than today, and the temperature, the global temperature, were higher than today, were about 2 degrees. Tsunamis strike most part of the coastal Mediterranean, mainly in the eastern part of the Mediterranean. So you may see this dotted blue line, which represent the probability of the occurrence of tsunamis for the next 50 years. So where dark colors correspond to higher probabilities and light colors correspond to minor probabilities. So North Africa, Eastern Mediterranean, Southern Italy and Greece are the most exposed to tsunami occurrence during the next 50 years. This is a map of the expected land flooding for the Venice Lagoon by 2050 at left and 2100 at right, so the end of the century. And this map has been realized by combining the vertical land movements from GPS data and from the climatic scenarios from IPCC calibrated for the Mediterranean. Thank you, and I ask you to stay tuned with Savemedcoasts results and through the website and social media like Twitter and Facebook. Thank you.